Welcome, students, to another video lecture with Mr. Kinnett here. Go ahead and pause your video lecture and begin to copy down what you see. Okay, welcome back. There is one revision I would like us all to make, if you don't mind helping me out. We are also going to learn about how to use the Pythagorean Theorem in this lesson. And a really funny sounding word for not a super hard formula to follow. So our focus throughout this lesson is we're learning about triangles, and our goal is to be able to find the exterior angle of a triangle, maybe a missing interior angle of a triangle, and even at the very end of the lesson, a missing side of the triangle. The key to most of the problems in this lesson, except for the Pythagorean theorem problems, is going to be the angle sum of a triangle formula. And what that states is that the sum of all interior angles, so interior angles are the angles inside of the triangle, have to add up to 180 degrees. And this is that simple formula that gets created from it. So in our example triangle here, we have angle or x, angle y, and angle z. And if you add up angle x, angle y, and angle z's dimensions in degrees, they have to equal 180 degrees. Yeah, so anytime we're trying to find missing angles inside of a triangle, or even missing angles on the exterior, we're likely going to have to utilize this formula to solve the problem. Just like all of our other lessons, we're going to review a little bit about triangles before we go into how we apply this into our algebra that we're learning now. So I'm going to jump 2 slides ahead, and please make sure that when you copy these down, you really clearly copy them down and you're not rushing yourself. It's going to be really important that you can read what we're doing and you can see how we're doing it. So go ahead and pause here and copy down what you see. Okay, welcome back, students. So we have our types of triangles, and I'm not going to read them for you. I think you can all read them yourself. But what is really something I'd like you to notice is in this line on the by angles, I'd like you to notice that every time that we would add the 3 numbers inside of these triangles, they always add up to what number? Yeah, whenever you add all 3 angles, they always add up to 180 degrees. So this is a really simple visual for how we're going to apply it more in our algebraic problems. So let's move on to example 1. And to make my life a little easier, I'm going to shift that slide over a little bit for me, which means you'll start seeing example 2. We're not going to work on that one just yet. So right now, our goal in example 1 is to find the measurement and realize these parentheses here where it says in degrees, they're not going to remind you about that, but I wanted to mention that in the first problem so you understand that your answer should be what you think the size of the angle is in degrees. So this is really similar to problems we did when we were finding the missing side of a perimeter problem on a rectangle, where we had to solve for the entire perimeter, get the variable solution, and then substitute back into the original expression to find the actual length of the side. So the most common mistake in this problem is students see angle A, and they set angle A to parentheses x plus 10 equal to 180. But that would mean that the entire angle A is 180 degrees. And what we're learning in this lesson is that all 3 angles added together have to equal 180 degrees. So back to our problem here. This would not be the correct setup. That is a common mistake students make. They love to just see angle A and they try and set angle A, but that's not using the theorem correct. So let's use it correctly. And we're going to recycle a skill we've used a lot this year. So first off, the simple expression is angle A plus angle B plus angle C all have to equal 180 degrees. We get that from our interior angle formula. Now, we're going to reuse that skill we learned way back in chapter 1, and I have continually stressed it is probably the most used property in mathematics. What property is that? Property that is the most used in mathematics. Yeah, if you said substitution, you're right. And if you didn't, it's time to go back to chapter 1 and review what the substitution property actually is. So right now, what we're about to do is we're going to substitute the expression for angle A into the actual equation we've created. So angle A's expression is 2 parenthesis x plus 10. We bring down the plus sign, and now we're going to substitute angle B's expression in where there isn't angle B in our equation. Then we have to add angle C, and angle C also has an expression. So we're substituting in for it now. These normally could be numbers, but I had to use a more complex problem as the model here, so I tried to make it a little harder, and I made every angle have an expression, and it's actually not too difficult. I'm hoping right now that we substituted, you start to realize that you've already been given a tool and a skill and a strategy to solve this equation from our past. Can you think of what sequence of steps we're going to have to use to solve for this variable in this equation? If you said Piam, you're right. And if you didn't, again, it's time to go back into Chapter 8 and remind ourselves our sequence of steps for solving any equation. So the first thing we have is the distributive property. And we have to distribute 2 to the x and the 10, and we get 2x plus 20. Plus sign still comes down, and now we have to distribute the 4 to the x and the 15, and we get 4x plus 60. And then we have to distribute our, what number is directly in front of this parenthesis? Can you see it? Yeah, you're using your mathematical skills to see the invisible 1. And that's what helps us get those parentheses to go away. Okay, we're just following our steps in Piam. Now we're combining like terms on each side. And we do have some like terms here. 2x plus 4x plus x is 7x. And I'm going to cross those out since we used them. And now we need to combine our constants. We have 20, 60, and 30. And that adds up to 110. We bring down the equal sign in the 180 number. Now we have to try and combine like terms across the equal sign. Do we have any variables that need to be brought from left to right? We don't. So there is no second L in this problem. We're now moving on to the additive inverse. And remember, that's when we start focusing on our constants. So we're going to have to use the additive inverse to get the constant away from our variable. And we end up with 7x equals 70. Great job so far. And now we got one more step to go here. We have to do the multiplicative inverse to get the 7 off of our x. And we have now discovered that x equals 10. Again, if you remember back to those perimeter problems, it's really common that students are like, sweet, I've done a lot of math. I got an answer. This must be done. But our problem is not asking for what the variable equals. It is asking for what is the measurement of angle A. What skill are we going to have to recycle one more time to find the actual number for angle A? Yeah, if you said substitution, you're correct. So we're going to write angle A equals 2 parenthesis x plus 10. Now we're going to substitute the variable we just solved for into the problem. And now it's just the order of operations. Oh, the answer is 40. Angle A's measurement is equal to 40 degrees. That's the answer. We've now answered the question they asked. A good way to check you have this problem done correctly would be to actually substitute the 10 back into angle B's expression and back into angle C's expression. And then when you add the 3 numbers you get for angle A, B, and C together, they should equal what number? Yeah, 180 degrees. All right, so let's go ahead and move on to example 2. In example 2, we're going to be stuck with trying to find the exterior angle. And I've realized I haven't had you copy this down, so go ahead and pause here and copy it down. Nice, I'll come back. So in this problem, we're trying to find the exterior angle, and that is our variable y in this problem. The biggest mistake most students have is they're like, how do I get y? Well, we're going to have to figure out what each of these angles are inside before we can actually figure out what y is. So first, let's figure out what x is. And to find that out, we're going to use that theorem again we're learning at the beginning of this lesson. Any three interior angles of a triangle have to add up to what number? Yeah, you're right, it's angle. It has to be 180 degrees. So 4x plus 3x plus 13x has to equal 180. We have no distributive. We do have like terms. That gets us up to 20x equals 180. There are no like terms across. We don't have an additive inverse, but we do have the multiplicative inverse. And we find x equals 9. So, again, not the answer to the problem. But now that we know that x equals 9, we can actually find out what the measurement of this angle is with the 4x in it. So, the angle for that is actually going to be 4 parentheses 9, which equals 36. So we now know that this interior angle is actually 36 degrees. We learned in a previous lesson that to create a straight line, it is actually 180 degrees whenever you have a straight line. So that means angle y plus our 36 degrees has to equal 180. So we have one more equation we're going to need to solve. I'm going to move to the next slide for that. So y plus 4x has to equal 180. I already substituted in for x, but I wanted to show the whole process you could have done it for. We now know that's a 9 for x because we discovered it. It equals 180. Y plus 36 equals 180. And now we got to do the additive inverse to get the variable by itself. So y is going to equal 144 degrees. Oh my! We've just discovered that the exterior angle in this problem equals 140 degrees. That's the answer. So, again, we're recycling a lot of skills here. None of this is really brand new. We're learning about that new theorem that all interior angles of a triangle add up to 180 degrees. But all of these other skills to solve for variables and substitute are recycled skills. So the last part of our lesson is going to teach us about the Pythagorean Theorem. I'm going to have you just pause here and copy down what you see. And I'm going to add one extra note before you actually do that. This formula only works on right angles. It can only be done on a very special triangle. It has to be a triangle that has a right angle. And we call those right triangles. So go ahead and pause to here, copy down what you see, and we'll create a Pythagorean theorem problem together in class. As always, if you have any questions, please write your questions in the question column and ask them in class. I'll see you soon, students.